We've been solving equations, and I wanted to make a little video on the special cases. So when there are no solutions or infinite number of solutions. So I kind of gave you a little bit of notes up here at the top. We've been solving problems all along that have worked out to x equals and then some particular number. I picked 13 because it's my favorite. That is a normal equation. So the specials are over here, and when we work out a special problem, we're going to end up with all of the letters dropping out, or we'll have something like x plus 13 equals x plus 13, but essentially it's 13 equals 13, and that will always happen no matter what x I choose, which means that I have an infinite number of solutions, because if I add an x here and I add an x here, I can pick any number in the world that I would like to put in there, and it would still be true. Now, on the opposite side of that, we have things that have no solutions. We'll work the whole math problem out, and then we'll end up with something like 13 equals 5, which we know is impossible. We can't have that particular number. So I'm just going to change it to the little not equal sign and write down that it is a no solution. And so we're going to try these three together so that you can kind of get a hang for what happens. I'd like to say that they're going to always come to you a nice and neat like this, but most of the time they're going to be wrapped up in a complicated multi-step problem, and you're going to have to do some combining like terms and distributive properties to go ahead and figure them out. So if I were to do my normal steps for these types of problems, I would see that I would now have 2x plus 3 and it equals 2x plus 3. Now I personally recognize that those are identical and that when I go ahead and subtract 2x from both sides, I'm going to get the 3 equals 3, which makes that infinite solutions, and so some teachers will actually use the infinity sign. So the same thing happens over here. The first thing I would do is I would do the distributive properties. So that would be 2 times 2 is 4x minus 2 minus 2. And again, I have two terms that are matching, and so I would highlight those, and I would now have 4x minus 4 equals 4x minus 5. Some of us at this point can already see that there's going to be a problem. If you don't, that's totally fine. Go ahead and subtract your 4x's from both sides, and you'll be left with negative 5 equals negative 4, which we know is impossible. So I'm going to go ahead and mark the little line through it, and I'm going to say no solution. Some teachers will use a symbol for that. It will be this. So if you need to put a symbol there, that would be the symbol that I would use. So if I were just going to look at this third one that I have constructed here, do you think that it matches more of the infinite or the no solution? You are correct. We're going to come down here. We're going to subtract the 4x from both sides, and we will be left with negative 2 equals 5, which we know is no solution. So that is exactly what we're going to do to solve these. I'm going to put up the next slide, and I'm going to ask you to pause the video, and that way you can practice this, and then at the end of the video you'll be able to see whether or not you have done them correctly. So I'm going to leave it right here for a second. That gives you time to pause the movie. How'd you do on the first two? Did you get them right? All right, try the next two. I hope you got all of those right. No solutions and infinite solutions are usually mixed in with a lot of problems that have a solution, so please don't assume that if a teacher gives you a specials worksheet or a specials assignment that every problem will work out to no solution or infinite solution. Many times they will look very similar to the ones that work out evenly. So, like I said, good luck.